In this video, let us discuss about the design of built-up sections. So what is a built-up section? See, when a single member is not enough to carry certain amount of load, then there comes this built-up section. So we are interested in talking about built-up columns in this chapter. So what is a built-up column or built-up compression member? See, you know what is a column? Column is a member that is subjected to axial loading. So if this is a column and this is the axis and this column is subjected to axial compression, the compressional force is going to be along the axis of the column. But what happens if the load is very high? When the load is very high, a member has to be increased in its dimension. You have to go for higher dimension, higher cross-sectional area section. So, but that is not economical all the time. So when the load is high, you cannot just simply go for bigger section. Okay. So bigger sections may not be available to suit that particular load coming onto that column. So in that case, what you are going to do is we are going to go for built up sections. So when the load is very high, when you cannot use already available rolled sections, you have to go for built up section. So in built up compression members, what we are going to do is you are going to combine two sections into one. Therefore, the load carrying capacity of these two columns is of these two members is going to be higher because these two are coming together to take the same amount of load. For example, if the load is something like 1000 kilonewton, very high load, so if single member is not sufficient or you have to go for higher sections, instead of going for higher sections, go for smaller sections only. Instead of one, go for two. Okay, you join these two sections. These two sections act as a single member and take this 1000 kilonewton of load. And this member, which is formed by joining these two individual members into a single member, is what we call as built up sections or built up columns, built up compression members. So these built up sections are very useful uh, in carrying higher amount of loads. And generally, steel columns are made up of channel sections, I sections, and angle sections. And similarly, you can join these angle sections, channel sections, and I sections to get built up compression members. See, for example, you can join four angle sections to get a column of this shape. Okay, of course, you are going to connect all these angle sections by a different system. And if this is an I section, this is an I section, you can join with these two with a system. And if it is a channel section, C section, you can join these two channel sections either this way or this way. Okay, we will talk about the connection later. Okay, but I hope you understood that built up members are the members formed by combining two or more rolled steel sections that are already available. And these built up sections are also called as combined columns or open web columns. And generally, based on the connection, we can classify these build-up columns compression members as laced member, struts with batten plates, and members with perforated cover plates. The difference is very small. Coming to this, see, when I'm saying that two individual members has to be connected, there is a connecting system. One of the connection system is lacing, lacing, and other one is batten, batten plates. And strut with batten plates and batten plates is a little difference. Okay, based on how these batten plates are used to connect these two plates. Okay, and laced members, in case of laced connection, we are going to use uh, these lacing bars. So these are nothing but lacing bars. So these lacing bars are oriented at an angle connecting this channel 1 and channel section 2, isn't it right? So this is nothing but lacing system. Okay, we use lacing bars, and these join these two channel sections and form a single built up section. Okay, and remember, when you go for this lacing system, the top end and the bottom end of the column should always be joined uh, with a tie plate. A tie plate has to be bolted or welded at the two ends of the column. Okay, even though the lacing is used. And in some cases, in the batten connection, what we do is we just go for only these tie plates. Only these tie plates are used. For example, see, this is a section and this is a section, and these two sections are just joined with this tie plates or batten plates, just batten plates. They're bolted or welded, no lacing bars, only tie plates, and that system is what we call as batten plates, I mean struts with batten plates. And in case of perforated cover plates, the plates that are used to connect these members are the connecting column members, individual members are perforated. You may have seen almara that is generally used in office, okay, for placing the stuff and everything, paperwork and everything. Okay, they are made up of iron, perforated angular sections. Okay, so let us go from here. And one other thing is, when coming to channel sections, okay, when coming to channel sections, that is C sections, they can be joined face to face or back to back. Okay, so you need to note this difference. Channel sections can be connected with face to face or back to back. What is face to face? See, if this is the channel section, this is face and this is back. So if face of a channel faces the face of the other channel, it is called as face to face connection. See, this is face and this is face. Face and face are opposite to each other. They are facing each other. So face to face connection. Okay, and see this figure B. In this section, in this column, the back of the channel sections are facing each other, so this is called as channel sections back to back connected. Okay, and here single lacing. So what is single lacing? So only a single bar is aligned, I mean, there is only one system of this lacing in this manner. It is what we call single lacing. But what happens in double lacing is, this is the tie plate and this is the tie plate at the bottom and the top. So in case of single lacing, this is how it looks, right? But in case of double lacing, this is how it looks. There is another system of lacing bars. Okay, of course, it increases the connection between these two channel sections. Okay, and there is also another thing that you need to know when coming to lacing. See, these lacing plates are joined in this manner, right? This plate here. Okay, it is inclined at an angle. So these can be joined in this way. I mean, these two lacing plates are not overlapping to each other. They are individually bolted or welded to the built-up column. Okay, but in some cases it can be this way. How is that? This way. So now see, this lacing bar 1 and lacing bar 2 are overlapping each other. Okay, these two bars, lacing bar 1 and 2, are overlapping each other onto this column section, and they are bolted here by using a single bolt. Okay, so both these uh, lacing bars are connected at the same point. Okay, this is important because when we solve problems, this makes a difference. Okay, but in this case one, what happens in the case one? These both lacing bars are individually connected at two different locations. They are not connected at the single point, different 2 points they are connected. Okay, right. See, this is channel section connected back to back by battens, battens. Battens are nothing but these tie plates that join. These are at regular intervals from the top to bottom. Okay, and these are connected with bolts or by weld. And if you see this figure D, you can see angular sections, angles are joined. Four angle sections are joined to form a built-up section. Okay, see here all the angle sections are facing, all the faces of these four angles are facing each other. Okay, facing each other. Now, coming to the reasons for built-up columns. Of course, I already mentioned one of the reasons for these built-up columns earlier. That is, it increases the load carrying capacity of the column. Okay, but how is that happening is, so instead of going for larger cross-sectional area, if cross-section is important, you can achieve that increase in cross-sectional area by joining two individual members. Okay, but you have to understand that sometimes it may not be economical. You have to balance that. Okay, so that is, see, if you wanted to, if you want a column to take some amount of load x, if the x load is very high, so you have to go for a very large cross sectional area, rolled sections. They may not be available in the market for you. Okay, so in that case, since you want a higher cross sectional area, you have to go for two individual cross sections coming together and forming a built up section. You have to go for built up sections for sure. Okay, and sometimes even though the larger cross sectional areas are available, sections are available, that may not be economical. So what we do is we bring together smaller cross sectional area members together and form a built up column. Okay, and we will use the lacing system to join them. But remember, when you are going for built up sections, you are using extra material for lacing. Okay, so you have to finally decide whether going for two smaller sections and building an built up section is economical, or going for a little bit higher cross sectional rolled section, a single rolled section. You have to decide that. Okay, but in case when you want a very high cross sectional area, there is no other option but going for the built up columns. And the other thing is provide special shape and depth which facilitates connections between different members. So when I'm saying different members, this can be between any two members. See, uh, if there is a column, for example, and there is a beam here, now if this beam and column has to be joined, okay, has to be joined, this built-up columns facilitate or makes it easier for joining these two members together. Okay, and third one is provide sufficient large radius of gyration in two different directions also. So let me give you a little more description about this point with this figure. See, in the first figure you see an individual channel section. Z axis is the horizontal, Y is the vertical axis, and this is the centroid. So now this IZZ is going to be higher than IYY, isn't it right? Okay, moment of area about Z axis is going to be higher compared to axis YY. And similarly, the radius of gyration is also going to be greater about ZZ compared to YY, because you know that radius of gyration is root over I by A. So I is proportional to radius of gyration. If radius of gyration is high, I is higher. If I is higher, that implies that radius of gyration is higher about that particular axis. Okay. So now this causes a problem. See, if this channel section is used, okay, is used as a column to take certain amount of load, what happens is this column is going to buckle about an axis that is weaker, that has less moment of inertia and less radius of gyration. So what can you say is this section is going to buckle about YY axis. అంటే ఇప్పుడు if this is the section, it is going to buckle in this way. Okay, about y axis, it is going to buckle because radius of gyration is small and moment of inertia is small. But what happens if I take another channel section and join these two channel sections face to face? Okay, this is, see, face and face facing each other. So what happens is now the y-axis will shift to the center of these two sections, isn't it right? Z-axis will not change. So what happens is, since y-axis has been shifted, now if you find out what is the IYY of the complete built-up section, it is going to be greater than the IYY of the individual section, isn't it right? So what is happening? By joining another channel section with the already existing section and making a built-up section will finally lead to the increase in moment of inertia and will increases the radius of gyration. And because of this, when the same amount of load is acting on this column, what happens is, since the moment of inertia about y-axis has been increased, it is not going to buckle that easy, isn't it right? So it is, we have an important point to mention here, that is, see, these two channel sections are going to be placed in this manner, right? Face to face or back to back also. But see, there is a spacing between these two sections, right? Isn't it right? This is the spacing between these two. So if we are going to join these two channel sections by lacing or batten something, okay, don't worry about that. So as I keep on increasing the space between these two channel sections, what happens to the moment of inertia about y and radius of gyration? It keeps on increasing. Before, when it is individual, IYY is greater, right? But when you come to these built-up sections, when you increase the spacing between the sections, this IYY keeps on increasing and it can even exceed the moment of inertia about ZZ axis. Okay, but what we are going to do is, practically we are going to provide spacing between these two channel sections so that IZZ is equals to IYY. Okay, this is important. Okay, so we are going to provide in such a way spacing between these two sections in such a way that the IZZ is equals to IYY. Okay, so this is the reason, this is important. When we are designing a built-up section, you also need to find out what should be the spacing between these two channel sections or two I sections or angular sections, any sections which you are joining, the spacing between them. So when you are calculating that spacing between the two sections that you need to provide, okay, this IZZ, okay, IZZ is taken to be minimum, I minimum, okay, because finally I wanted to have the built-up section moment of inertia equal to IZZ, right? So what I need to do is, so I mean, what happens to this built-up section if IZZ is equals to IYY? What is I minimum? IZZ or IYY, anything, right? So I don't know what is IYY of this whole built-up section, but I know what is IZZ of this built-up section, because even though it is individual member or two members coming together, this Z, moment of inertia about Z has not been changed. Okay, so IZZ can be calculated, I mean, can be obtained from the steel table or the code book, right? So you can take that value to calculate the spacing that you need to provide between these two sections. In the next video, we are going to discuss about the steps for the design of built-up columns. Thank you, everyone.